Hi developers, in this video I'll show you a platform that will revolutionize the way you write unit tests. This platform will allow you to write unit tests directly against your database. So you don't need anymore to write mock or to abstract the data access layer. This platform uses the snapshot. How it works? Just before you start running your unit test, this platform will create a snapshot of your database. This includes the schema and the data. It will save that snapshot onto your disk. Then you run your unit test, so you can add, edit, or delete data from your database. And at the end of your unit test, the snapshot will be restored to your database. So your database will retrieve its initial state as exactly just before start running the unit test. So this way you don't have the problem of losing data from your database after running the unit test. This will allow us to run unit tests against the database, which in itself allows us to discover errors and bugs more quickly. And this process could be done automatically for each unit test against our database. This platform is called CaveTester, and today it is available as an open source project on GitHub. I'm Hossein Delai, Microsoft MVP. Join me in the next 10 minutes to talk you more about this platform and how it works. It's open source and it's published on GitHub, so you can take a look at its source code. Mainly, this project have the SQL Server DB snapshot. This one have those two main methods for create and restore. Create will try to create the snapshot, save it to your disk. Then the restore will try to restore your original database. So that between those two states, you can write your unit tests, because at the end of your unit tests, you are sure that you will get the original database, the original data. How we can write unit tests using this framework? So here I have a sample app that just saves a list of tuples, and here I start with setting up the connection to my database. So here I'm using a SQL Server right here, and here I have the connection string in order to connect to my database. I'm also connected to my database using SQL Server Object Explorer, and here I have my tables for turrets. After that, here I create an instance of DB context. And this DB context, actually it connects to the real database. Note here it takes options here which contains the real connection string for my real database. After that, we'll go and create a snapshot. So this will create like a copy of our data along with the schema. Then we'll go and save that copy in our local disk. After that, we'll create an instance of turret service. This one will change the database. So the scenario here is that I'll go and add some other data to my database. Then I'll save those data to my real database. Then I'll go and act right here by removing all defective turrets. So all the turrets that have is defective equal to true, they will be deleted from the database. After that, we'll assert, so we'll check our database or our table if we have yet some defective turrets. So we should not find any of those. After that, we run our unit test. We'll go and restore the original database here by using savehandler.restore all. Let's debug this unit test and to be able to understand how it works exactly. So here I have a breakpoint right here. I'll go from here and say debug. When it's doing that, let's take a look at my database right here. I go to my table. Let's go to my table right here and click View Data. And here, when the unit test starts debugging, let's go and check the data in my table right here. So I'll go and say View Data. And here I have this table with those only two rows, the first one and the second one. I'll go and run until this line of code. And until here it executed those two lines of code. This will create the snapshot in our local disk. So if I go here to my project /bin/debug, then right here I can find that now I have a CaveTester db.ss for snapshot saved in my local disk. So this is the file that was generated by the framework in order to save the state, the original state for and the original data coming from my database. Then here I go and create a new instance of my storage service. Then I'll add some data. So if I go until here, or actually let's move until this one right here. So for here we have created and saved data to our database. So if I go back to my table and refresh again, I should be able to see the new data that I have added. After that, now we are ready to run the remove all defective turrets, to remove all the turrets that is defective equal to true. So let's do that, and let's stop by the assert right here. So now if I go back to my table, I should be able to see that is defective equal to true. They should be deleted. And here they are actually deleted. Now I run my assert to check that everything is okay. Then I'll go, now that I have finished running my unit test, now I'm ready to get back the original data back to my database. And that could be done by running restore all. I'll go and continue. So here my unit test runs successfully against the real database, and more interestingly, if I go back to my table right here and do refresh, note that here we'll get the original data back to my table. And that's the power of this framework. You can actually run your unit tests against the real database, and at any time you can restore back your database. And here another feature in this framework is that you don't need to write all this extra code for generating the snapshot and then restoring it in each unit test. Actually, we can refactor this code. So the result would be a test like this. This is the equivalent to the test we saw earlier. So here you see we don't have almost any lines of code for creating or restoring the snapshot, because this could be done inside a configuration file. I hope you like this framework, and again, it's open source on GitHub, and we are welcoming your contributions. So thank you.